So this is Chemistry 2.2, Atomic Structure and the Periodic Table. The diagram below shows the electronic structure of an element in the periodic table. So the first thing I did was work out what that element was. So I looked at what group it was in, what period it was in, and then I could easily find it on the periodic table. Use an X, represent an electron, and draw the similar structure to show the electron structure of the element which lies directly below. So when I looked for sodium, the one that lies directly below is potassium, and I've drawn exactly what potassium would look like. Potassium has essentially got an extra shell from sodium. Then it says lies directly to the right of the one on the periodic table. So sodium, next to sodium is magnesium. Not to be confused, you don't go and look at what potassium looks like and what's next to potassium. You've got to go back to the original element. So magnesium is just one group over from sodium. So instead of having one in its outer shell like sodium, it's got two. Moving on then to the bottom of the first question, carbon has two different types of atoms which are represented like that. So they've both got the same atomic number, so the same number of protons and electrons, and then different mass numbers, which means that they have got different numbers of neutrons. Give the term used to describe different types of atoms of the same element, that is isotopes. Moving on then to question number 2, okay? An awful lot of pupils will forget to fill in the table, okay, because there's no line. You need to be looking, complete the table for 3 marks. 3 marks you cannot afford to throw away. So, A, working out the mass number. All you've got to do, the mass number essentially equals protons plus neutrons, so just add them together, 3 plus 4, and that'll give you the mass number. B was completed. C, you're working out the atomic number. So the atomic number is the same as the number of protons, so you're looking at 6. D was then completed, and then E, you're looking at the number of neutrons. So you've got the mass number, which is 23. You've got the number of protons, which is 11. So essentially the mass number should equal the protons plus neutrons. So you're looking at what number do you add to 11 to get to 23, and that will be 12. Give the electron structure, so how many electrons are in each shell. So the electron structure of D, so it's got an atomic number of, what's the atomic number? Atomic number of 10, so that means there's 2 in the first shell, because you're going to fit 2 in the first shell, and then 8 in the second shell. Use this information to explain why this element is found in period 2, group 0. So group 0 means it's got a full outer shell, so 8 in its outer shell, and period 2 means it has 2 shells, so 1, 2. Part C then says choose from the letters A to the atoms that represent isotopes. So isotopes have got different mass numbers but same atomic numbers. So you're looking for things that have got different. So essentially what I would do is look for the ones that have got the same atomic number. So that's B and C. Go down, they've got different mass numbers. So B and C are isotopes because they've got the same atomic number but a different mass number. Question number 3 then is looking at group 1 alkali metals and their reaction with the air. So 3 freshly cut pieces of lithium, potassium and sodium are left exposed to the atmosphere. What will happen to them? They'll go from shiny, straight away they'll start to tarnish. They'll go back to that off grey colour. Describes how the reactions will differ. Potassium will tarnish the fastest, lithium the slowest, because reactivity increases down the group. So reactivity increases down the group, with lithium being the least reactive element in group 1. A, B and C represent group 7 elements, the halogens, bromine, chlorine and iodine, but not necessarily in that order. The table below shows the results observed when A, B and C react with hot iron wool. So it's looking at how quickly they react after a few seconds, after a few minutes, instantly. Using the information above, work out which element is work out which one of these results is each element in group 7. So I've put bromine as A, so reacts in a few seconds, iodine as B, reacts in a few minutes, and then I've put chlorine as C, as it reacts straight away. Chlorine, and then I've given the reason for that. Chlorine is the most reactive halogen. Chlorine reacts with iron wool, forming iron chloride. Write a balanced symbol equation for the reaction of chlorine and iron. So looking here, as you can see, I've done in pink pen. It's a bit of trial and error. So I've first off in the purple pen, as you can see here and here, I've worked out how many of each element I've got on each side, and then I've looked to see where I need to increase the elements. A good thing to do is look at, with your chlorines, what are they both multiples of. So essentially if you times them by each other, you'd end up with 6. So how do you get them both to equal 6? And then I've done iron then, working out then what iron would be is 2. What I would do, say, is to work out how you're going to make this one the same as this side, because something like iron on its own, you can change it as many times as you want because it's not reacting with anything else on that side. So, moving on now to question number 4. So question number 4 was about noble gases. So noble gases, their atomic mass increases down the group. So does their density, looking at melting points and then boiling points. Describe a trend in the melting points going down the group. Melting point increases down the group, okay? That is a little bit of a confusing one because they're negative, but the negative number is getting less. So that means they increase down the group, okay? Use the data in the table to estimate the melting point of argon. You're looking at something that's between neon and krypton. So I went bang in the middle, minus 200. All group 0 elements are gases at room temperature. State how the information in the table supports this. Their melting and boiling points are all below 0. Okay, so remember, melting would be turning from a solid to a liquid, and boiling would be turning from a liquid to a gas. So if any of these numbers were above 0, then you'd expect them to be a liquid at room temperature. Helium is used to fill party balloons. Give one property not shown in the table that makes helium suitable for this purpose. You could talk about density. You could also talk about how it's diatomic, so it's unreactive. Moving on then to part E. Again, another balancing equation. As you can see, these come up quite often, and they may be worth 1, 2, 3 marks, but they do come up quite often. As you can see, again, I've started with the purple pen, and I've just worked out how many I've got on each side. So actually, my xeons were balanced. My oxygens weren't. So the first thing I did was try and make my oxygens balanced, and then unfortunately I ended up with 2 xeons on this side, so then I had to make it 2 xeons on that side, so they were all balanced. Finally then, question number 5, which is the 6-mark question. And as you can see at the bottom, I've done like a little bit of work before I started answering the question. So I've looked at the topic, group 7, important mark 6, so we'd be expecting to see at least 6 bullet points of information. Even if you don't write in full sentences, bullet point it, 6 marks. Command word, so the command word was describe, so say what you see. Keywords, reactivity, size, 7 electrons, and then I've started to think of a sentence starter so I can get myself started. So the elements in group 7 react by. So the question, describe how the reactions involving chlorine, bromine and iodine can be used to show a trend in reactivity of group 7. You should include equations in your answer. There are 2 main reactions which group 7 can be involved in, and they are with alkali metals and iron wool. Both show the reactivity decreases down the group. Group 1 metals, the less reactive element will displace the more reactive element. So sodium, iodine and chlorine. Chlorine's obviously higher up in the group, so it's more reactive, so it will displace iodine from the element, and you end up with sodium chloride and iodine. And I've just done a little symbol equation as well, so I've done 2 types of equations there, word equation and a symbol equation. And then I've talked about iron. Fluorine reacts instantly, whereas iodine still reacts but requires a lot of heat to speed up the reaction. Okay, so fluorine's top of the group, so that's the most reactive halogen. Again, proving that the more reactive halogen is at the top of the group.